Before showing you the components, I want to tell you what we can check in universal testing machine. Mainly we can do tensile test, by which we can measure tensile strength, yield strength and percentage elongation of the material. We can also check the bend test. By bend test, we can measure or check the ductility of the material. Now I am showing you the components. This is upper claw set and you can see there is two jaw fitted in there and the space in between for tensile sample, and this is movable claw set. There is also two jaw which is fitted inside of movable claw set. We can move the claw set up and down. As you can see, I am keeping it down. Similarly, we can up it by pressing the up button. And the space in between, this is for compression test. We can keep the sample here and do the compression test. For this, we have different types of mandals also. We can install the mandal here and do the bend test. So this is the sample for tensile test. We can take different types of material and different types of sample, but generally we do flat sample or round sample. For today's tensile test, we do round solid sample. Before starting the test, we have to measure the gauge length. Basically, we measure gauge length because to determine the percentage elongation of the material. So at first we are measuring the dia of this round solid. This is 16 mm. So the gauge length will be 5.65 root over cross sectional area. So it will be 80. So we will take gauge length 80 and mark it . As you can see, we put the sample in UTM and there is a control unit. There is two main components in the control unit. One is hydraulic power unit and one is speed limit unit. Before starting the test, we have to close the hydraulic power unit. And after starting the test, we will increase the power gradually depending on how much speed we need. As our machine is computerized, we can see the reports in computer also. For this, we have to give input data in the computer. For this, we are opening a new file. We can keep the file name as Tensile Test. Our sample outer dia is 16, so this is okay. Gauge length is also 80. We will do the yield calculation, so we will keep it in yes. Company name XYZ and everything is okay now. I am saving it. Now we will do the start test. In there is outer dia is also written as 16, gauge length is 80. Everything is okay. Safe load is 600 kilonewton. That is alright. And we will make the yield by graph. So this is also fine. So we are starting the test and we have to give 10 to 20 seconds of preload, switching on the machine and giving preload around 10 seconds. preload is given around 10 seconds. Now I am adding the load. And starting the test now. As you can see, load is increasing gradually. And you can see below the load rate, displacement rate and time. And the graph is making now. You can see the notch here, that is yield strength at around 59.720 in between 74.650, and load is still increasing, that is 129.9. So we got the yield here. This is the yield point. Now the load is getting lowered now. You can see the cup and cone shape in middle. So this is two broken parts. I have to measure the elongated gauge length now. We marked the gauge length before starting the test is 80. So this is now 98.3. So I keeping it at 98.3. Now the final dia. The final dia is, as I can see, the specimen has cup and cone shape in the breaking part. This is 12.4. So dia reduced to 12.4 from 16. Now if I close the report and result is saved, the report is already published, and you can see the report. The tensile strength is 0.647 kilonewton per millimeter square. Yield stress is 0.365 kilonewton per millimeter square. And the elongation is 22.875%. This is the report, and you can see the elongation is there, and there is yield strength, and there is tensile strength. Okay.